Cody Hendrickson. Today we're looking at how you can properly answer the AP free response section for the computer science exam. We're going to go over a quick little outline of what we're going to be addressing today. First, we're going to talk about the idea of timing for the exam, making sure that we're actually addressing all the components of the exam itself. Then we're going to look at the reading and the backgrounding that was required for the exam. We're going to talk about the tools we have available when we're taking the test, looking at some diagram and other methods we can use to prep for the questions themselves. Then we're going to look at how to answer a method type question, then how to answer design type questions, and then finally some general analysis review so we can actually prepare for all the questions just in general for the AP free response section. First, we want to look at the idea of timing. So as of the 2016 test, we now only have 90 minutes total for the free response section. That's 15 minutes less than had existed in previous years, so you want to make sure you properly allocate your time. What we want to do first is we want to make sure we have some time to actually look through all the questions. The reason being is that the questions themselves are not organized from easy to hard. The first question may not necessarily be the easiest or the hardest, so we want to actually look through all the questions to identify what we want to do. The other thing we can do is this allows us the chance to actually go through and give our declare and return variables as needed for our actual methods, giving us a little bit of work ahead so we have, I have to have an int in this method, so let's make sure I declare an int, assign a value, and return it right as we go through the actual test review itself. Then we want to spend about 20 minutes per question. That gives us time to actually answer all the questions. These questions are not designed to be overwhelming, so 20 minutes is a good rough time to give each question for that. Finally, spend about 3 minutes or so to review all of what we've done inside the actual free response section. We want to look over all of our code, making sure we've checked off all the components we've already identified as we went through and did our overview, answered the questions, and made sure that we met all the post conditions for the actual question itself. So just a brief little structure of how we want to do every single free response section of the AP test. Next, we look at the idea of reading the actual AP free response section. We have multiple pages in this document. If you look at the sampled questions that are available on apcentral.com, you'll see these are 25 pages per packet for each year's worth of questions. We have quite a few pages of information we have to review. A couple of the key things we can do when actually going over this is we want to identify our verbs and our nouns. If you haven't already talked about this in your AP class, you want to look at the idea that a noun can represent the idea of an object or a data member within a class, and the verb represents the actions or the methods of the class that they'll be performing. So by identifying those nouns and verbs within the actual documentation that is supplied on the AP exam, we're able to identify what we're using and what we need to do inside our code. The next thing we look at is the idea of the post conditions. Those post conditions are what is expected to be true after the actual method has been called. So this is information like, I've done this, now this should be happening. So by looking at those post conditions that are attached to the methods that are we'll be writing inside the AP exam, we identify, at the end of the method, this is true, this is true, this is true. We know what we're doing for the actual code. Also, we want to make sure we grab the key concept. This is that big picture idea. What are the main things we have to do as we scan through and read the questions themselves? And so by identifying that, we have a picture in our mind of what has to happen. We get that key concept of, we're doing this in this class. One of the things we can always use for that is the idea of our good variable naming conventions. So we actually write down what makes sense and what we'll actually understand when we go back and review it again in a few minutes. And lastly, we want to make sure we read it again. It's in bold, it's in caps, because we want to actually go through and check it again. That first quick glance through the actual documentation and the code that goes along with that, we may have missed something. So please read it a second time. By taking the time to just quickly read it again, we can make sure that we're identifying all the key components that should be existing within our own code and what is actually supplied to us inside the pre-existing code that the AP exam gives us. So make sure we read it carefully the second time. We don't get a lot of tools when we're taking the AP exam besides our brain, of course. However, we do have access to pencils and pens we can take in the exam. Again, remember, you don't get to take a highlighter in the exam, so we want to make sure we have a good supply of pencils and pens with us, more than just one, so in case of lead or ink dries out, we have availability for it. But more important than that, we have the idea that we can mark up our booklet. This booklet is designed to be written on and added information to. Use that ability to write on it. Don't be afraid to mark out things and identify stuff. Specifically, there's a couple things we want to make sure we do when we're actually going through and taking the exam. The first step is using circles. We want to make sure we identify the objects we have to instantiate. What are the things we have to make? By circling those objects we have to instantiate, the data members and the parameters that we need to use, if they are given to us as a parameter or as a data member, that's a clue to us as the answerer of the document that is an important thing of information that we should be using within our own actual solution to the question. We're going to receive a penalty because we're redoing code that already exists, which violates many of the principles attached to object-oriented programming. The second step that we want to do when we're marking up our booklet is underlining the actions we need to perform. Again, these are the idea of the verbs that are going to be attached to what's happening, the actions that are occurring, and those will actually correspond basically directly to the lines of code we need to write, because each line of code should represent a single statement or action that we're doing, and by identifying those actions that we're performing, they're either in the post conditions, or specified within the actual question documentation itself, we identify what should be going inside the code of our method. Finally, after we've gone through and written our code, we want to go through and either star or check off the things that we've accomplished. This is a great little tool for us as a test taker. Oh, I've done this, check it off. I've done this, make it a little star. These are the things I've accomplished, making sure that I've gone through and after looking at my actual code, looking at the post conditions, and looking at what the problem description says, I've accomplished these tasks. Great way to make sure we get as many points as possible when writing the exam. Looking at the idea of a diagram. Now, some questions are going to be really helpful for this to create our own visual representation. Other questions may have a picture that's given to us by the AP test. However, the idea of creating some representation of what we need to do, whether it be a diagram or some pseudocode, this is a great way to help organize our thoughts even further as we're actually taking the exam. Remember, of course, you have only a set amount of time, again, about 20 minutes per question to answer all those questions. But giving that time to actually set some time up to answer those questions, you can quickly identify what has to happen. Again, we're not talking at a formal activity or sequence diagram for this, but rather, oh, I need to do this, then this, then this. By simply writing those instructions out that are explained in the post conditions or in the documentation itself, it forces you as the writer of the solution to identify those key components yourself, and it helps prepare you for what code you have to write inside the actual exam. This also gives us a chance to look at the question again. We are able to understand more closely what we're trying to solve when we do this quick little diagram or pseudocode that is attached to the actual question. Now, many of the questions on the AP exam will provide a visual example for us, whether it's a form of a graph, a picture, or something else like that. We want to make sure that we take a look at this. However, as stated right here, do not code for the sample. The sample is simply there to actually look at, to say, oh, when reading the question, here's a picture of what it might look like inside one specific instance. Again, the key idea is one specific instance. This is not the solution. This is not the only set of information we'll be solving for, but rather here is one set of information we could possibly use. So it is there to help us get a visual representation of our ideas, because many of us use a picture to help organize our ideas, and that is a sample that is given to us by the AP exam to help us identify what should be happening inside the code. We cannot stress this enough. Do not code for the sample. If it gives you a picture of a 2D array, do not code for the number of rows and columns specified in the actual sample, but rather call the appropriate sub-zero dot length for columns or the dot length for the number of rows for that 2D array variable, rather than simply specifying, oh, that's at row 3. We want to make sure we specifically identify that we're using the data members that are attached to the question and the objects that are within the question, rather than specific samples that are given outside a picture. Looking at the idea of a method-based question. First thing we want to do when we're doing a method-based question is identify what are the needs of the question. What do we need to do? By looking through the question, identifying the verbs themselves, underlining each of them as they happen, and circling the objects that need to be used or parameters that need to be used that are also given to us inside the header of the method, we identify what are the actual needs of the question. Parameters specifically are a key component of a method-based question. If a parameter is given to you inside a method header, that is a giant, huge, big, bold, red, underlined, starred clue that use me. Make sure I call this parameter and use it properly inside my code. If you're given a parameter, it's a nice bit of information that's probably specified very clearly inside the documentation of the question itself. Many times inside the AP free response, we'll be doing something repeatedly to the code. You will see a reference to this by, say, traverse the array, or for everything in this, do that. When you see any clue that it has something happening more than once, that's a key indication that we want to use a loop. Personally, most of the time I'll use a for loop for that, because we're often using a data structure, and I can use the built-in size variable for the data structure or the size method for an array list to actually identify how many times my loop should execute. And so I recommend clearly looking at the idea of the number of loops. If there is any indication that you're doing something more than once, that's a clue to actually put a loop in your code, and that's something that we can also use by putting that loop in and attaching code inside that loop. That's a quick way to make sure we get some points inside the question for the actual solution we submit, even if our code is not completely correct. By realizing that there is a repetition of code that needs to happen and using the loop appropriately, that's a great way to get some points for actual solution. The fourth one on there is the return type. Now, looking at the idea of a return type, we want to make sure that we identify as soon as we look at our method header that there is a return type for that individual method that we are writing. One of the key things on that is we want to make sure that we identify that return method and then write it inside our method immediately. That is a clue for us that that's a quick way to immediately get some points by initializing a data member and doing it immediately. Finally, if there is any data structure within our method, make sure that we access it appropriately and do not destroy the data structure unless that is called for explicitly inside our instructions. Many questions will expect us to use an array or an array list of objects that we're going to be using for something inside the question, and to do so, we need to make sure we use that data structure properly. If we are dealing with an array, we want to make sure that we're using the square bracket with the index specified inside the brackets, or if we use an array list, that we're using the appropriate methods, the .get, .set, .add, .remove methods that we've been using all year. So check to make sure you're using the correct data structure and using the appropriate methods or lack of methods appropriately if you're using an array. Again, looking at the idea when dealing with a return type method, we have a couple samples right here where we can see that we are having a couple different return type methods that have some of that. If we look at the first method on the left, we see that it has calculating some information about a year, and it gives a valid year between the number 1900 and 2016, expecting that we were actually doing something with that. And so because it's an int method, the first line on that is declaring an int variable. Again, notice that we are not using the keyword private because it's an internal or method variable, so we don't need a visibility modifier attached to it. We give it a variable name that makes sense, and we assign a valid answer to it. In this case, I'm using the bottom end of the acceptable range of numbers, and then I have a comment there to I would appropriately put my code in there for solving the solution, and my last line of code for the method is returning the variable. That way I can, regardless of whatever changes I make inside my code, that the appropriate logic happens and I return, no matter what, an appropriate value for my data member for that method. On the other side, we have another sample with an object one on that. In this case, it has the information is specified as there is a parameter in there that I should be using, and that I have a data member of an array, I have a return type, an array list of type string, and I'm going to be doing some logic based on the fact that there is a grade level I need to match, and based on that grade level, remove all students who do not match that, or don't match that grade level. So obviously within that, I would need to have a for loop that would need to go through and remove things from it. Based on the fact that there's inside that string, there's going to be some information that doesn't match that. So we have an information that's attached to that. I have an array list that is properly declared and initialized, not set to null, and I return that appropriately initialized array list. So we have the idea that we declare a variable, initialize it with an appropriate value, and finally return it as our first step of writing any of our method-based questions. If we're going to be doing a class design-based question, again, the first step, as always, is identify the needs. What does that class need to do? The first step on that is obviously going to be looking at the constructor, looking for how do we build said object. Do we have to provide more than one constructor inside this? Is there going to be a default constructor with no parameters, or will we have a multi-parameter based constructor? We also want to make sure that any data members that are implied or listed inside the class specification or the question specification are properly defined inside our class as well. Because we're following good object-oriented programming techniques, we want to make sure that our data members are declared as private for encapsulation and visibility, and also that they're the correct type. Don't define everything as an int. There are a variety of data types available. Use the appropriate data type for the appropriate variable. Make sure you check that against the documentation and the preconditions that are specified inside the question. Finally, make sure that we write any methods that are required or implied to be needed inside the question. We don't have to write extra methods, but if it says that you will need a getter for these values, or you need to access these the data members externally, we obviously will need to have a getter method for them. If we have a method that must be calculating something, make sure that calculation method is properly defined inside our code. And again, check to make sure that all of your return types are specified as hinted in the question itself. In the last couple of years, we've also had quite a few interface-based questions. Interface question, it means we're going to have to actually be a little bit more abstract and deal with that. So when we identify needs, we're identifying what are the methods that are going to be shared across all these different objects, and making sure we identify how those methods are implemented in the different versions of said object that implement that method. So when we're doing the actual interface, if we're writing the interface itself, we want to make sure that we are writing only the prototype of the method, or that header for the method only. So it would have the visibility always of public, it would have the method name as appropriate, any parameters that would go inside the parens, followed by a semicolon. Remember, with an interface, that there are no squiggles used for the methods themselves. It is simply visibility public. It has the return type of the method, whichever type it may be, the method name itself, any parameters that would exist inside the parens, followed by a semicolon. And for each of these, they'd be listed in there. Remember that if we're dealing with an interface, that our methods need to be public because they have to be shared across all of them, and we want to make sure we get that taken care of. On the other half of the question, we have the idea of implementing that interface. When we implement the interface, we want to make sure that the class header for the class that is implementing that interface has the keyword implements in it, so it'd be public class, whichever class implements said interface. And so we want to make sure we have that specified clearly within our code that we're writing for the question. We want to make sure that every method that is specified in the interface is properly implemented, aka it has open and close parens, open and close squiggles for each of those methods. And however the method needs to be implemented is filled within the squiggles themselves of that method. So check to make sure that those methods are actually properly implemented based on what is specified in the interface itself. In general, we want to look at a couple things for the actual design itself. We always want to make sure that we assign values to our variables. If we were putting a method in our code, if we're using a variable in that, you want to make sure the first thing you do is assign it a valid value. If we have a variable inside a method that has no value, there's no expectation of what's stored inside it, which will cause compilation errors, which will make our code not run. So you always want to make sure that any variable you are using inside a method is properly assigned a valid type, or valid value, excuse me. Return statements are one of the quick things to check as we go back through our project. As we step back through all the questions on the AP Free Response exam, we want to make sure that we have assigned return statements to every one of the questions that have a return type attached to it. So if it is an int, string, array list, array, whichever return type that method has, make sure that you have a variable defined of that type, initialized and returned as the last line of code for each of those methods that have a return type attached to it. With clean code, we want to make sure that we have our code clean, organized, and easy to read. We want to make sure that we have this as a one line of we want to make sure that we have one line per action. We don't need to do any complex or convoluted or tricksy bits of code. This is not the time to impress your knowledge of using multiple statements in one single line, but rather have one line execute one event. Make sure this it's easy to read and easy to understand, so that regardless of how your code is read, there's no chance of messing up and having someone who's reading your code misunderstand what you're trying to do. The big thing on there, number 4, is the KISS principle. If you haven't heard of this before, it's the keep it stupidly simple. Make sure your code does only what it has to do. Don't add extra features to your code. That's not what the AP exam is all about. Make your code answer the question, and that's it. Do this thing, that thing, and that thing, the things that are specified in the post conditions or in the documentation for the class. Don't do anything else. A big thing on this is do not have any output. Make sure there are no system.out.printlns within your code, because that is a guaranteed reason for a deduction of your answer. So make sure you answer exactly what it says, keep it simple, do exactly what it says, and no more. Finally, in general, the idea of handwriting. Many of us have poor handwriting. Okay, we deal with that. A couple things we can do to make sure that our handwriting is clear and easy to understand is make sure we use letters that are easily understandable. Make sure our variable names are clearly defined and spelled correctly. So if you have a problem separating your G's, your R's, and your C's, make sure that they are clearly visible and you can explain what's going on. If your ampersands look really bad, provide a little comment saying, here's what my ampersand is this is an ampersand. This is what it's supposed to look like, I know, but here's what my ampersand looks like. Giving those quick little explanations to the grader of the exam may help us read that. We can't grade the comments, but if we realize that your little fishy shaped thing with a plus in it is actually an ampersand, we'll have a better idea of how to actually understand what we're grading in the code. Again, if you have poor handwriting, another quick way to fix that is to use the idea of small and big caps. By having everything in capital letters, you can easily read what's being in there, and by having a big cap for the capital letter for using mixed case notation, it's very easy to understand what you're trying to read. Always, another thing is to make your handwriting a little bit bigger than you normally would write. Tiny handwriting is not going to be very helpful for people reading the exam. Make sure your handwriting is tall enough that it can be easily read by anybody, not just a person with a magnifying glass. So make sure your code is clear, easy to read, and that will make your handwriting a lot better. Some resources you have available. There's a Sunny Day in May article on AP Central that's available. It talks about some of these processes and some other examples of how to actually write stuff to make the exam look better. And this is available for both students and teachers, so they can use that on AP Central. Again, you also have the previous questions that are available on AP Central from 2016 all the way back to 1999. You can look at any one of those questions that are available on AP Central and use those as a practice source. I highly recommend that you try other questions, even ones in other languages, because it allows you to actually build up some practice in answering those free response questions. Realize that those questions, all the answers are available, but it's a great way to keep practicing for understanding how to make sure you write solutions that match the rubric that is attached to those questions. And finally, if you're looking to develop your own questions or something to practice with on your own outside of class, the idea of using some word problems from your math or science textbooks or math or science textbooks of your younger siblings. By looking at those quick little word problems, they ask a question and expect you to solve it. You can usually generate a quick free response question for yourself by looking at that of the question and generating the code that would necessarily solve that specific problem. We can use that as a great way to practice to see what's happening and making sure that when we use that code, if we actually implement it and test it, make sure it would give us the right answer. So those are some things to prepare for the AP free response question.